Hello friends, this video on areas related to circles part 5 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched part 1 to part 4. Let's understand the sector of the circle. So there are two kind of sector. One is major sector and one is minor sector. So if you have a circle in the center O, draw two lines and this point touches the circle. The minor one is called minor arc, the major is called major arc. For example, if we have a more circle like this, draw this point. So this is called minor arc and this way is called major arc. Why? Because this angle is less than 180. So the area which is smaller, where the angle is less than 180, is called minor sector. The whole thing is called sector and this thing is called also sector. So this is nothing but major sector. And this guy is nothing but minor sector. Correct? Similarly, this line from A to B is called arc. This is called minor arc. And from here AQB, example I say AQB, this line from here, this is called major arc, and this one APB is called minor arc. APB, this is called minor arc. Now let's see what is major and minor segment. So if you have this circle, big circle, and this chord AB, divide the circle into two parts. The one which covers maximum area or more area is called major segment, and the one which covers lesser area is called minor segment. So the one in the blue is minor and the one in the white is major. For example, again we have one circle like this, and this is a chord AB again which divide the circle into two area, 1 and 2. The one in the lesser area is called minor segment and the one with the bigger area is called major segment. So please note the difference. In case of segment, this is a chord that divides the circle into two area. In case of R, you have two radius that divide the circle into two area. Example, this is minor sector and this is major sector. So this is the example of sector where the area is divided by the radius at the center, and in this case it is the chord that divides, so it is segment. Please note, in case of segment, the chord divides circle into two parts. In case of sector, it is this radius and this center and this arc. This divides circle into two parts. So this is the major sector, this is minor sector. Similarly here this is a major segment and this is minor segment. So let's have some note for sector and segment. So when we write segment or sector in normal case without minor or major, we mean minor segment and minor sector. That means when I say sector A, sector, some sector of circle, that means we are talking about minor sector. And I'm saying some segment of any circle, I'm talking about minor segment. So if minor or major is not specified, the default one is minor only. Correct? If I just say segment, just a sector, I mean minor sector and minor segment. So let's see the area of sector of a circle. So in this case, if we have this circle and we have the sector and the angle separated is theta, the radius is r, the area of the sector, the blue part, will be theta by 360 into pi r square. Logically also, if you see, if you start from a one point, the whole circle is 360 degree angle, right? So out of 360 degree, I am talking about only theta for the area. So the area will be theta by 360. If you put theta is equal to 180, you will get 180 by 360 by pi r square, that is pi by 2 r square, that is area of this sector. Correct? So the area of sector, the default formula is theta by 360 into pi r square, where theta is the angle subtended by the radius and 360 we know is the this whole angle, so this will be constant, and pi r square where r is radius of the circle. Similarly, the length of the sector, for example, this length of sector, this sector if you want to find this length of sector APB, this will be theta by 360 into 2 pi r. So instead of pi r square, it is 2 pi r. When we are talking about the area of the sector, we are telling pi r square. When I am talking about the length of the sector, I am telling 2 pi r. Why? Because this theta is the angle subtended, 360 is the total angle. Theta by 360 will be the angle subtended by the length by this angle. So that will be APB. Correct? So this will be theta by 360 into 2 pi r. So this is nothing but APB. This length is the length we are talking about. Theta by 360 into 2 pi r. Similarly, the area of the segment. So we have this chord AB. This divides the circle into two half, not exactly half, two part 1 and this whole thing is part 2. So we have to find the area of the segment. This is the area of the blue colored region. So for this, there is no direct formula. So what we have to do, we have to first find the area of this sector, the whole sector, and then we have to subtract this triangle AOB. That is, we have to find the area of sector OAPB, this whole thing we have to find. This we can find as nothing but theta by 360 into pi r square. From this, we have to subtract this triangle OAB, and then we will get the area of the segment. So there is no direct formula to find the area of the segment. To find the area of the segment, we have to see how it is constructed. So in this case, it is area of the whole sector minus area of the triangle. We'll take some examples. You have to find the area of the sector of the circle with radius 6 cm and the angle subtended by sector is 60 degree. So this angle is 60 degree and this r is 6 cm. So we have to find here area of the sector, right? So area of sector, we know the formula is what? Theta by 360 degree. Since it is area of sector, so it is pi r square. Correct? We'll put the value. Theta is equal to 60 and by 360 degree is constant. Pi will say 22 by 7. R is 6 into 6. Correct? So this becomes 1 by 6 and 6 cancels. So what I get is 132 by 7 and the unit is centimeter. So it will be centimeter square. Why? Because we are talking about area, and that is my answer. Very simple. To find the area of sector, theta is given, theta by 360 into pi r square. Here r also given, find the value. Let's take one example. Find the area of the quadrant of a circle whose circumference is 22 centimeters. So you have to find the area of this quadrant, where the circumference is 22 centimeters. So we know that area of the quadrant is nothing but the angle subtended is 90 degree. That is 90 degree by 360 degree into pi r square. So we know theta 90, we know we have to find the value of r. How to find the value of r? We are told circumference is 22. Since circumference is 22, we can find the value of r. How? We know that circumference is nothing but 2 pi r, and this value is nothing but 22. It's nothing but 2 into pi is 22 by 7 into r. So from this, if we solve, we get r is equal to, this cancels, 7 by 2. So r is 7 by 2. We have got the value of r. Now we have to find the area of quadrant. Area of quadrant. Please note it is a quadrant. Quadrant means this area, because one complete circle we divide into 4 parts. Quad means 4 part. This is 90 degree. And this particular area we are talking about is nothing but 90 degree by 360 degree, because theta is 90 into pi is 22 by 7, r square, it is 7 by 2 into 7 by 2. Correct? But the formula we are using is theta by 360 pi r square. So this becomes 1 by 4 and To solve this, this and this gets cancelled, 11. This is also cancelled. So what you get 7 into 11 is 77. 4 into 2 is 8. 77 by 8. This is centimeter. We are talking about area. So the unit is centimeter square, and this is my answer. Very simple. What we have done? We first found the radius, and then we use formula. Area of quadrant is nothing but theta by 360 pi r squared. Theta is 90 and r is the radius which we found. Got the answer. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.